in this lesson we're going to be talking about solving your system by substitution. So remember, substitution just means you take one thing and you plug it in somewhere else. So the first thing you're going to do is you're going to solve one of your equations for either x or y. Then you're going to take and substitute that expression from that you got when you solved into the other equation for that variable. And then you're just going to work it out. Once you work it out, then you're going to plug that number back in. All right, which probably doesn't make a whole lot of sense because we haven't done one yet. So if I look at this, I'm going to solve one of these for either x or y. So if you look at this, y is already by itself, correct? So that means that y is equal to all of this, which means they're interchangeable, right? So everywhere I see a y, I can replace it with negative 2x minus 9. So that means that where this y is right here, I can take that and plug it in for the y down here, which is what I'm going to do. So I've got 6x minus 5. And then since this is 5 times y, I'm going to have to put a parenthesis when I plug in the negative 2x minus 9. And then I've got equals negative 19. So all I've done is, I know that y is all of this, right? So I can take all of that and put it in for y in the other equation. Now, do you notice all I have are x values, right? I don't have any y's. That's the whole goal. You shouldn't have a y now. That way you can solve for x. So I'm going to go ahead and simplify this. I see that I have a negative 5 that's in front of a parenthesis, so I should distribute that. So I'm going to keep the negative 6 out front, and I'm going to distribute this negative 5. So negative 5 times negative 2x gives me positive 10x. And negative 5 times negative 9 gives me a positive 45. And there's nothing for me to simplify over here, so I've just got the equals negative 19. So now I've got 6x and 10x, and these are both on the same side. So I'm not doing anything that's the inverse or the opposite. I'm just putting them together. So if I take a 6 plus a 10, that's going to give me 16x plus 45 equals negative 19. So now that I've simplified that whole side, like I can't put anything else together, I'm going to solve for x. So I'm going to go ahead and subtract the 45 from both sides. That's going to give me 16x is equal to negative 64, if my math serves me correctly. All right, and then I'm going to go ahead and divide by the 16, and that gives me an x value of negative 4. So I know that my point, remember when you solve a system, you get a point in return, right? So I know that the x value of my point is negative 4. Now I'm just missing the y value. So the easiest way to get that, right, is to take my x value and plug it in up here in one of these. It doesn't matter which one, but I would think it would be easier to put it in the first one because y is already by itself, right? So I've got y is equal to negative 2, and then I'm going to plug in that x value that I just found for the x in this equation. So plug that in, and then I've got a minus 9 behind that. And then I can just plug that in all at once, which is going to give me 8 minus 9, which is negative 1. So the y value is negative 1, and that's my answer. You don't have to write it at the top, but you can write it at the bottom, wherever. I just like to stick it at the top. Just make sure you circle it. So once you find one of the variables, then you just plug that in to the equation. Now, let's say that I did this one. I could do that. If I did 6 times negative 4, right? If I plug the negative 4 in right there, minus 5y equals negative 19. So I got negative 24 minus 5y equals negative 19. I would have to add the 24. And I get negative 5y equals positive 5. Divide by negative 5, and 5 divided by negative 5 is negative 1. So it doesn't matter, but wasn't it much easier to plug into this one because y was already by itself? So sometimes you can make more work for yourself if you don't know what you should be doing. So number 2. So in one of these, I'm going to solve for y. Notice y is already by itself in this one, or I could have solved for x if I wanted to. But I know that y is equal to all of this, which means I can take that and plug it in for y in the other equation. So notice y is all by itself over here, so I don't have to worry about any parentheses. I just need those if there's going to be something being multiplied by that. So I plug that in for the y, and then I have equals negative 4x. Now I have x over here and I have an x over here. I want to get the x's together, so I'm going to subtract 3x so I can move it to the other side. Remember, we only have to do the opposite when we're moving it across the equal sign. So on this side I have 14, and on this side I have negative 7x, and then I'm just going to divide by negative 7 to get that x by itself. So x is equal to negative 2. So now I have found my x value. I can take it up here and plug it into one of these. It doesn't matter which one you plug into. I can plug into this one or I can plug into this one. I kind of think it might be easier to plug into the second one. So that's what I'm going to do. I've got negative 4 times, and then I'm plugging in my x value that I just found, negative 2. So negative 4 times negative 2 is positive 8. And remember, this would be the point of intersection. So I've got negative 2, comma, and then the y value is 8. So these two lines will cross at negative 2, 8. And a good way to check yourself is you could graph both of them, right? Solve for y, graph them, and see if that's where they cross. That's a good way to check yourself. Also, you could plug in the negative 2 for x and the 8 for y and make sure that both sides equal. So on number 3, notice that they've solved for x, like x is already by itself. So that means that all of this can be plugged in to the x in the other equation. Make sure you're paying attention to what letter you have by itself. So I'm going to plug all of this on the right side in for the x in the other one. And this time I do need parentheses because I'm multiplying by a 4. So I've got a 4, and then I'm going to plug in for that x. I'm just going to take it out and put 6y minus 7 in its place. Then behind that I've got plus y equals negative 3. Now it's just simplifying. Notice this time I'm finding y first, right? That's all I have are y's. I don't want to have x's and y's. I just want one or the other. So I'm going to distribute the 4. 4 times 6y is 24y. And 4 times negative 7 is negative 28. Don't take the 4 times the y back here, right? That's not in the parentheses. So I've got plus y equals negative 3. So I'm going to go ahead. On this side, I have some y's to put together. So I have a positive 24y and a positive 1y, which makes 25y minus 28 equals negative 3. Now that I have just that y right there, I'm going to go ahead and solve. So I'm going to add the 28. So I have 25y is equal to 25. I'm going to divide by the 25 that's being multiplied by that y right there. And anything divided by itself is 1. So my y value is 1. Now remember, that's the second number of your point. So now you're going to go up and plug into one of these equations, but you're going to plug in for y because that's the y value. And since x is the one you're looking for and it's already by itself in this equation, we're going to plug into this top one. But remember, it doesn't matter. You could plug into either one and it will work. So I've got x equals 6, and then I'm going to plug in my y value of 1, so 6 times 1 minus 7. That gives me a y value of negative 1. So my point of intersection is, x value of negative 1, sorry. I'm doing what I told y'all not to do. All right, so my x value is -1, and my y value is 1. So these two lines would cross at the point -1, 1. All right, so now let's throw in a couple where we haven't solved for a variable yet. So if you look at this, neither one of these has the x solved for or the y solved for. So it doesn't matter which one you choose. You can choose to solve for x. You can choose to solve for y in the top one, in the bottom one. It's really just your choice. I like to look at the one that's probably the least amount of work. So if I look at this, if I want to solve for y here, notice there's nothing being multiplied by y, so all I would have to do is move this x over. So that's the one I'm going to work with. So I'm taking the top equation. I'm going to solve this for y. So I add the x. And remember, if we're going to put this in order right here in standard form, we want to put the x in front of the 3. So we have a positive x and a positive 3. All right. Now this looks exactly like what we were given in the first two examples. We can go ahead and take this. This is what y is equal to. And I can plug that in for the y in the other equation. You always have to go to the other equation. So I've got 3x plus, now I want to point this out. This is plus 1 times y, right? There's nothing here that I need to distribute. If this was a minus sign right here, I would have to distribute a negative, but there's not. So I really don't need parentheses here. So I'm just going to plug in the x plus 3. If you like to put the parentheses like this, you can, but it's just not needed because there's nothing to distribute, okay? But if you like to put them just so you can, then take them off, that's fine. All right, and then we have equals -1. All right, so I look on this side. I need to get my x's together. They're on the same side, so I'm just going to combine them. 3x plus a 1x gives me 4x. And then I have the plus 3 equals -1. So I'm going to go ahead and solve for x. I subtract the 3. So I have 4x is equal to -4. Then I'm going to divide by the 4. So x is -1. Then once I get that, I'm going to take and plug in to one of my originals. Now, here's the thing. You can plug into one of these up here, or I can plug into the one that I rewrote, because this is the same thing as this up here, right? I just rearranged it. So I'm going to go ahead and, it's kind of risky sometimes to use something that you manipulated already, but it's just easier to plug into that. So I'm going to take the y equals, and I'm going to plug in the -1 right here for my x. So I've got -1 plus 3. So I get a y value of 2. So the point of intersection would be x value of -1, comma, my y value of 2, and I'm done. So just to reiterate, this is the one that I manipulated, right? It's the same thing as this equation up here. I just moved the x, right? And so that's why I can still plug into that one if I want to. And it's actually shorter if I do, but I definitely want to make sure that that was correct in the beginning. All right, so on number 5, we want to solve for either x or y. It doesn't matter which one. Again, I'm going to look for the one that's the easiest. Like, I don't want to solve for this x right here because I'd have to move the y over, and then I would have to divide by this -3, right? So I can choose to solve for this y because it has a 1 in front. This y has a 1 in front. This x has a 1 in front. Those are the easiest ones to solve for when the variable just has a 1. Are they always going to have 1s? No, okay? But I want to choose the easiest way. So I feel like it's easy. We solve for y all the time. I feel like y is easy to solve for. So if I want to solve for y here, all I have to do is move this x over. So I'm going to choose the top equation to manipulate. So I'm going to go ahead and subtract the x so I can get the y by itself. And if we're putting this in standard form, we're going to make sure that we put the -x in front of the -2. And I'm going to put a star here because later when I plug in, I'm probably going to want to plug into this equation right here. All right, so I know that y is equivalent to this over here. It's the same thing. They are equal. So I can take that and plug it into y in the other equation. So I've got negative 3x plus, and this is where you're going to assess whether you need parentheses or not. I just have plus a 1y. I don't need parentheses if it's a plus, right? If there's a minus sign there, I have to have the parentheses so I can distribute the negative, but there's no minus sign there. So I've got negative x minus 2. And I'm not a fan of plus a negative, but we're going to leave it like that. Equals 6. All right, now I can combine these terms that are on this side, so the negative 3x and the negative 1x, that makes negative 4x. And then I have minus 2 equals 6. And now since I've got my x's together, I'm just going to solve for x. So I add 2, negative 4x is equal to 8, divide by negative 4, and x is equal to negative 2. So I know my x value. I'm going to plug in. Now remember, you can plug into one of these if you want to. I can plug the negative 2 in here, or I can plug the negative 2 in here, or I can use that equation that I manipulated because I'm solving for y, right? I already have my x, so I can plug in right here. I just need to be careful because there's a negative in front of that x. So when I write this, I've got y equals negative, and then since there's a negative, I'm going to put parentheses when I plug in my negative here. So I have negative, negative 2, and then minus 2 behind that. So if I plug that in, I'm going to get 2 minus 2, which is 0. So the point of intersection, I have an x value of negative 2 and a y value of 0. That's where my two lines are going to cross. All right, so for number 6, we have to solve for either x or y. So what I'm going to do is I'm going to look at my x and y values. Are there any that have a 1 in front of them? 3, negative 2, negative 2, x. This x has a 1, right? So this is the easiest one to solve for. So I'm going to go ahead and take that top equation. Now, you're not wrong if you solve for a different one. It's just going to be more work for you. So I'm going to add the 2y because I want to get that x by itself. And I always put my variables in front of any kind of constant that I have. So I'm going to put the 2y in front of the 7. It's not really wrong for this case. If you put it behind the 7, that's fine. All right, so I know I'm going to put a star here because later I'm going to have to solve for the x. I know that x is the same thing as all of this on the other side. That means that I can take that and plug it in for x in the other equation. So I'm going to be plugging in for this x. Now, notice there is something in front of that x, a number or a negative, so I need parentheses when I put it in. I've got 3 times, and then I'm going to replace x with 2y plus 7. And then I've got everything behind that, minus 2y equals 3. So I have a little more work this time because I have that number in the front. So I'm going to distribute that. 3 times 2y is 6y. And then I'm going to take the 3 times the 7, which is 21. And then remember, we're not distributing 3 to this because it's not in the parentheses. So minus 2y equals 3. Now notice, my y's are on the same side, so I'm just going to put them together. 6y and negative 2y add together to make 4y. Then I still have my plus 21 equals 3. And then I'm going to solve for y, so I subtract 21. So 4y is equal to negative 18. And then I'm going to divide by 4. So that gives me y is equal to, Negative 18 divided by 4 is going to give you negative 9 over 2. So now I know my y value, so I'm going to plug that in. So remember, I can plug that in to one of these two, or since I know I'm solving for x and I've already done that here, I can just plug in for that y value right there. So x is equal to 2, and then I'm going to plug in for the y. I need parentheses because I'm multiplying. Negative 9 over 2. And then we have a plus 7 behind that. So if I plug that in, that is equal to negative 2. So my point of intersection would be an x value of negative 2 and a y value of negative 9 halves. Please don't give me mixed numbers. I want an improper fraction. So there's my point of intersection. All right, so on number 7, let's decide which one of these would be easiest to solve for. So both of these have numbers in front, 2 and 3. This y has a negative 1 and this y has a negative 1. So either one of these is, the same. It doesn't matter. So I'll just do the top one. So I'm going to solve for the y here. I'm going to go ahead and move the x over. So subtract the 2x. I have negative y is equal to negative 2x minus 5. But this time I'm going to have to go one step further and get rid of that negative in front of my y. So I'm going to divide everything by negative 1. So that gives me positive y. This will be positive 2x and a positive 5. And then later when I plug in, this would be a good equation to plug in because I'm going to end up solving for that y in the end. So once you solve for that variable, just put a star there. All right, so I know that y is equal to everything on this side. So I'm going to take all of that and plug it into the other equation, so whichever one I didn't solve for, which would be this one. I'm going to plug in for this y. And I'm going to need parentheses because in front of that y I have a negative. Remember, if I have a negative or a number, I'm going to need parentheses. If it's just a plus with no number in front, then I don't. So I have 3x minus, and then I'm going to put in parentheses, the 2x plus 5. And then we have equals 1. So now I need to simplify here. This is a negative 1 right here, correct? So I'm going to keep the 3x out front, and then I need to distribute the negative 1. So negative 1 times 2x is negative 2x. And negative 1 times positive 5 is negative 5 equals 1. Now I see that my x's are on the same side, so I'm going to go ahead and just combine those. 3x minus 2x is 1x, but because we know that that's a 1, we're not going to write it. And then I have minus 5 equals 1. So the only thing I have to do to solve for this x here is just add 5. So I get an x value of 6. Then I'm going to take that x value of 6 and I'm going to plug it in for x. I'm going to use this equation right here since y is already by itself. So I have y equals 2 times, and I'm going to plug in the 6 plus 5. So I get a y value of 17. So my x value is 6, my y value is 17, and that is my point of intersection. All right, a drama club earns, I'll put an S there, $1,040 from a production. A total of 64 adult tickets and 132 student tickets are sold. An adult ticket costs twice as much as a student ticket. Write a system of linear equations that represents the situation. What is the price of each type of ticket? So we have two types of tickets, right? Let's just say X represents our adult tickets, and we'll let the Y represent the student tickets. All right? So we know that we earned a total of $1,040, so that's going to be after our equal sign. And that's made up of 64 adults, so that would be 64 times X, and 132 students, so 132Y. Then this statement is going to be our other one. An adult ticket costs twice as much as a student ticket. So if you have trouble with these sentences, then write yourself, like, think about it. So an adult ticket, like, give me a price for an adult ticket. Like, let's just say they're $5, right? So an adult ticket is 5. Well, let's make that 10. An adult ticket is 10. Let's say a student ticket, it says the adult ticket is twice as much as the student ticket. So how much would the student ticket be? $5, because this is twice as much, right? So this is 2 times the student, correct? So my adult ticket is equal to 2 times my student ticket. So just make yourself a little thing and say, okay, if my adult ticket is 10, that's twice as much as what the student is, so the student has to be 5. Like, think of it like that, and then when you write your equation, you can say, okay, this is twice as much as this. All right? So notice X is already solved for, correct? So that means that I can take whatever X is equal to, that's a Y, right? I love it when I change the variables. I can take everything that X is, right, and I can plug that in for X in this equation. So I'm going to do that. I have 64, and then I do need parentheses because there's a number connected to my X, right? I'm multiplying. So I'm going to plug in the 2Y plus 132Y is equal to 1040. So same thing that we've been doing. We've got 64 times 2Y, which would give me 128Y plus the 132Y is equal to 1040. So I'm going to go ahead and put together my Y values. They're on the same side. So I have 128 plus 132, which is going to give me 260Y equals 1040. And then I'm going to solve for Y by dividing by the 260. So 1040 divided by 260 gives me 4. All right, and then to get the price of the other ticket, all I have to do is plug in for the Y on that equation where the other variable was solved for, correct? So I've got X is equal to 2, and then I'm going to plug in the Y value times 4, which is 8. All right, so the Y represents your student ticket, and the adult ticket is 8. So you would say your adult ticket or adult tickets are $8, and student tickets are $4, which makes sense, right? Because the adult ticket is twice as much as the student ticket. 4 times 2 gives you the 8. And there you have it.